Hello everyone. So today we're discussing a concept based on kinematics. Let us read the question first. A stick AB of length L stands vertically on a horizontal floor, leaning on a wall. A beetle P starts climbing the stick from the floor. When the beetle starts climbing, the lower end of the stick is made to move away from the wall with a constant velocity v. The beetle climbs the stick with a constant speed of u relative to the stick. If the upper end A does not leave the contact with the wall, then what is the maximum height that the beetle can rise? Okay. So I have already drawn one diagram regarding the same here. At some random time, the beetle, which has started from here earlier, has reached, let us say, here. At this moment, the angle that the stick makes with the horizontal, let us say it is theta, and let us say the beetle has covered some distance, which is this much. Let's call this distance as some x. This much distance it has covered, and the total length of my ladder or my stick, sorry, is actually L. Okay. Now, if you understand, the beetle traveled a distance on the stick with a velocity u related to the stick. So if I say that this situation that we are seeing is after some time t, then we can say that the x that is there, the distance covered by the beetle, is nothing but u into t, where u is the speed with which the beetle is climbing that stick and time taken is basically the t. So I'll get this distance as ut. Okay. And we want the beetle to reach the maximum height during its journey. We can understand that as the beetle is climbing, the stick is actually falling off like this, right? It's leaning and falling onto the center of mass of the stick is actually falling down. But that means after some height, the beetle's height will actually start decreasing. After the beetle has climbed some distance, after that, after some time, the beetle's height will start decreasing. So initially the beetle's height keeps increasing, and then the beetle height will start decreasing because of the falling of the stick. So that means there will be a maximum height somewhere, and that height is what they're asking us to find out. Let us say at this moment the height that the beetle has achieved is h. Okay. So initially the stick was, how they said, the stick standard vertically initially. That means initially this distance was 0. Now at this time, how much distance has it covered means they have said in the question that this end is actually traveling with the velocity of v with respect to ground. So this distance that we are seeing right now will be nothing but vt, right? So the lower end of the stick traveled a distance of vt. In that same amount of time, the beetle has traveled a distance of ut. Okay. And this is the height of the beetle. I can write that the height of the beetle, let's see, the small triangle I can take. In this height is h. This distance we don't know, but this distance I know it as x. So by using trigonometry, I can say that sine of theta is equals to h by x. So basically h is equals to x, which is nothing but ut times sine theta. Now, as per the question, I have to maximize this h. To maximize the h, I can differentiate that. But while differentiating, by with the which variable will I do? Because time is also a variable and theta is also a variable. So I'll have to convert this variable. Because I'm interested in finding the maximum height, um, shall we write the theta as a function of time? Because in this diagram, I can see that I can get theta as a function of time using the bigger triangle. See, in this bigger triangle, I can get the sine theta, actually cos theta, as cos of theta will be Vt divided by L, adjacent by hypotenuse, Vt by L. So if I want sine theta, I can write it as Ut under root of 1 minus cos square theta, which is V square T square by L square. Yes. So this is my H. I want this H to become maximum. That means I will differentiate this. I can write dH by dt value should be equal to 0. So it's going to be a big differentiation, right? Because a root function is there. So differentiation will come out to be, let us take the, okay, I'll do UV method. So the first term u I'll write separately. Now inside the multiplication I'll have to do. So it will be under root of 1 minus v square t square by L square. Basically I have differentiated the first t. Okay. Now plus t as it is, differentiating the second term. So t as it is, differentiation of this would become 1 by 2 times of under root of same value 1 minus v square t square by L square. Okay. And into differentiation of the inside value, this will become 0. So then I'll be having a minus of 2 v square t divided by L square. This is what I'll be having, and that is equal to 0. Okay. Now last step, I can take maybe LCM here, and I can write it as this term will come here. So it will become 2 times of 1 minus v square t square by L square plus, not plus, this minus and plus will become minus actually. And then it will become 2 times of v square t square by L square divided by 2 times root of 1 minus v square t square by L square. This whole term has to be multiplied by u, and that's equal to 0. Okay, so just checking the calculation, 2 times of 1 minus v square t square by L square minus of 2 times v square t square by L square. Correct. Okay. Now if this has to become 0, the possibility is that numerator should become 0. So for that, what I can do is I will be having it as 2 times or 2 equal to, this will become same term, so it will become 4 times. So 4 times of v square t square by L square. This is what I'll get. And from here, I can write it as t is equal to L divided by root 2v. This is what I'm getting. Right? So once again, I found out the h as a function of time, differentiated the h with respect to time, equated it to 0. I found out the time for which the h becomes maximum. Now they are interested in finding the h max. So just substitute the value here. So if you want h max, then we can say h max is equals to u into t. The t we have calculated is L by root 2v under root of 1 minus v square by L square into t square value we have got as L square by 2v square. So L square gets cancelled, v square gets cancelled. I'll be getting it as 1 minus 1 by 2, which will be also 1 by 2, which will finally give me ul by 2v. Okay, so this is my h max, right? Okay, so as per the question, we were interested to find h max, right? Yeah, they were asking us to find out the h max, right? So we have got the h max. So this is the solution. We can stop here, but if you think about it, there is one more possibility here. It's a very interesting possibility. It's like, according to our discussion, if the beetle was not able to reach this point before the maximum height was achieved, that is when I'll be getting this as the maximum height. Try to understand the scenario. As the insect is climbing up the insect, the stick is actually falling down, right? So when will the insect be able to reach the maximum height? Means this time, right? But what if the insect is able to reach to the other end? What if the velocity of the insect is so high that before this ladder, before the stick could cover a distance of vt for which the h becomes maximum, before that, if the insect reaches here, then imagine this velocity of the insect to be very high compared to this v. Just think about it. Then before even the stick could actually cover some distance, the beetle would already be reaching here. Then what's the maximum height of the beetle? We can say that height. this height would be the maximum height, right? So this condition is correct. This answer is absolutely correct. No problem. But what if the velocity of the beetle is much more than the time taken to reach there? Right? The velocity of the stick compared to that, if it is bigger. So I would write the equation like this. I would say, what if, what if that L by which what velocity it is moving that side? U. So what if I say L by U? What is this time? This is the time taken by beetle, beetle to reach other end of other end of the stick. Okay. What if this time L by U is lesser than L by root 2V? Which means basically if you cancel the L's, you'll get it as what? Root 2V is lesser than U. Okay, or I can say V is lesser than U by root 2, anything. The point is, what if the beetle is too fast? That's the whole point. Okay, so what if the beetle is too fast? Then instead of reaching to a maximum height here, the beetle would already be on the other side of the stick, and that will become the maximum. So if that is the case, then we can say that if this condition is happening, then then beetle reaches its maximum height when t equals to L by U. At this condition, the beetle will reach its maximum height. See, according to our normal calculation, when the beetle will reach this time, correct. But if the beetle speed is high, then beetle would have already reached to this point. So time taken is nothing but L by U, the velocity with which it is traveling. So in that time, it has reached the maximum height. So this would be the time at which it reaches the maximum height. This is the second case. Okay. So if that is the case, means I can find out the H max in that one as H max equal to the same formula. I can use this one, U into, instead of time, I can put the time as L by U under root of 1 minus V square by L square, and then t square, which is nothing but L square by U square. So this would finally give me that H max equals to L times under root of 1 minus V square by U square. So this is also a possible maximum height. Both the heights are possible. Okay, this is also possible, that's also possible, depending on the beetle's velocity. So it's a very nice question on mechanics. Okay, the concept is actually very simple once you understand the solution. But when you look at the question, like most of us will be trying to get this answer, we won't be able to figure out that one. So that part is kind of a tricky one. I hope you have understood. Okay, we'll stop here then. Thank you.